Hey guys, how's it going? So the part of the course we're switching into right now, and guys, this is for 31 AP or just regular Math 31 as well. It's called Applications of Derivatives, and the first part we're going to be doing is what we call curve sketching. All right, so for curve sketching, the idea is like if you have a function like that, it's like can you actually figure out what this graph is going to look like? Okay, if you understand like all the properties of the functions like that, and how is this graph going to be able to look? Now, guys, we have graphing calculators for this stuff as well, but we need to be able to understand like why everything works the way it does like that, and be able to understand the stuff in a bit more detail as well. All right, so what we're going to find, guys, is at the end of this chapter, the question is going to be like, kind of say sketch f of x. Sorry. Discuss the curve f of x equals, say, 1 over x squared in terms of we'll say A, intercepts, B, domain, we'll say C, symmetry, talking about even or odd functions over here. D would be like intervals of, or sorry, D would be like asymptotes. Asymptotes as well. E would be intervals of increase and decrease. F would be local or absolute max mins. G would be intervals of concavity / points of inflection, and then H would be sketch the curve. So the idea, guys, is this is what we're doing. So we're looking at some function, and can we answer all these questions based on this one function, and then at the end you can build a sketch it. Okay. Now, guys, obviously we can't do all this stuff right now. You haven't even heard of some of these things over here yet. But so what we're doing for this unit, guys, we're going to teach you how to do all of these different parts individually, and then at the end we're kind of putting it all together by kind of drawing these curves as well. Okay. So for the first one over here, we're talking about intercepts. Okay, so how do you figure out the x and y intercepts? So to figure out x-intercept, or let's figure out y-intercepts. Y-intercepts is you want to set x equal to 0. So this would be like 2 times 0 squared plus 7 times 0 minus 15. So we get 0, comma, negative 15 is our x-intercept. For our y-intercept, for our x-intercepts, we make y equal to 0, and we solve for x. All right, so we get 2x minus 3, and then x plus 5. So we get x equals 3 over 2, and then x equals negative 5. Okay, so our intercepts here would be like 3 halves, 0, and negative 5, comma 0 over here. Okay, guys, I'm not going to do all these ones over here. It's pretty much going to be the same steps over here. Let's take a look at this guy over here. Let's do f at 0. So let's figure out our y-intercept first. This is going to be 2 times 0 minus 3 over 0 squared plus 3 equals negative 3 over 3 equals negative 1. Okay, so we have 0, comma, negative 1 is our y-intercept. For our x-intercept, we go 0 equals 2x minus 3 over x squared plus 3 and we multiply both sides times x squared plus 3. So we get 0 equals 2x minus 3. Add 3, divide by 2. 3 over 2 equals x. Okay, so we'd have like 3 over 2, comma 0, and that's going to be our x-intercept for this guy. Okay, so guys, it's really kind of all we're doing for x and y intercepts, guys. We've done this before in other units before in all of math 10, 20, and 30 leading up to this point, guys. So this is how we figure out intercepts. New topic over here, and if you guys took Math 30 AP, we would have covered even and odd functions fairly briefly in that course, guys, but we could kind of review for this guy over here. So for f of x equals x squared, if we had to figure out what f of negative x equals, well, that would be negative x squared, which equals x squared. Let's quickly talk about this, guys. F of x equals x squared is a parabola like this. Okay, and so this is like y equals f of x. And if we graph y equals f of negative x, it's going to be a reflection in the y-axis over here. Okay, so the point I'm trying to get at for this function over here is that the function f of x is the same thing as the function of f of negative x. Okay, this function is symmetrical about the y-axis over here. Okay. Now, what we have over here, an even function is defined as a function that's symmetrical with the y-axis. If f of x equals f of negative x, the function is even. Okay, so y equals x squared is an example of an even function. Other examples, if we graph y equals cosine of x, which would look something like this, this guy is also going to be symmetrical about the y-axis. So this is an example of another even function that we have over here. Okay, we'll talk more about trig functions later on in the course, guys. So we won't talk too much more about this one over here. Okay, now in this case, negative f of x would be y equals negative out in front of x squared over here. Okay, so and this would be a reflection in the x-axis over here. Okay, now if we have f of x equals x cubed, if we have to do f of negative x, that would be negative x cubed, which is negative x times negative x times negative x is negative x cubed, like this. And if I do negative f of x, that means I would put the negative out in front, and these guys over here. Now, the point we're trying to get over here is this is an example of an odd function. An odd function is defined as a function whose reflection about the x-axis is equal to a reflection about the y-axis. In other words, if f of negative x equals negative f of x, the function is odd. A little bit of more terminology here. Sometimes we say that odd functions are symmetrical about the origin. All right, so this kind of terminology that we use for odd functions sometimes. All right, example 4. State whether each function is even, odd, or neither. Okay, so here's how we do this. Okay, first of all, I'm going to figure out what is f of negative x. Well, that would be 4 times negative x cubed minus 5 equals negative 4x cubed minus 5. Okay. Now let's figure out, well, what is negative f of x? That's going to equal negative 4x cubed minus 5 equals negative 4x cubed plus 5. Okay, so if we're looking at this, hopefully we see that our function f of x does not equal f of negative x. Okay, so in other words, this function here is not the same as this function over here. So therefore, the function is not even. So therefore, not even. Okay. Also, f of negative x, that's this guy here, does not equal negative f of x. Okay. This guy has a minus 5. This guy has a plus 5. Those guys are definitely not the same. Okay. So these guys are not the same. Therefore, it's not odd. Okay, so this function over here is neither odd nor even. Okay, let's take a look at example B. So if I do f of negative x, I get negative x over negative x squared plus 3, which is negative x over x squared plus 3. If we do negative f of x, same thing as putting out a negative in front of the whole thing. And hopefully see if I have a negative out in front, I can just bring the negative to the numerator, like this. Okay, so what we're seeing here is that this function, first of all, the original function and f of negative x are not the same. So f of x does not equal f of negative x. Therefore, f is not even. But in this case, we have f of negative x does equal negative f of x. So in other words, this function is the same as this function over here, and that's f of negative x and negative f of x. Therefore, f is odd. Okay, let's take a look at example C. So guys, hopefully what we're seeing here is that when we square a negative x, we just get x squared. And we take negative x to the power of 4, we just get x to the power of 4 as well, which is the same as we had in the original. So f of x equals f of negative x. Therefore, f is even. Okay. If we see, guys, if we do negative f of x, we get negative out in front, x squared minus 2 over 5 minus x to the 4th, which is like negative x squared plus 2 over 5 minus x to the 4th. And this is not the same thing as f of negative x. So f of negative x does not equal negative f of x. Therefore, f is not odd. All right, so guys, this is what we're talking about for the first part of this unit. We're talking about how to figure out intercepts. So for y-intercepts, you set x equal to 0, solve for y, and to figure out the y-intercept, you set, for y-intercepts, you set x to 0, solve for y. For x-intercepts, you set y to 0 and then solve for x. And then the even or odd test that we've done over here is kind of how we showed you over here. If f of x equals f negative x, it is even, like we saw in example C. And if f of negative x equals negative f of x, the function is odd, like we saw in example B. Okay, in example A was neither even nor odd. All right, guys, I will see you in the next video.